Okay, so this is the last section out of chapter 4. And you're going to be applying the substitution, graphing, and elimination methods. So let's see. So this is 4.5, so it's system of linear equations and problem solving. So yes, that does mean word problems. All right, so problem solving steps. Understand the problem. So in other words, if you need to read the problem 4 or 5 times until it makes sense, then read it 4 or 5 times. Choose 2 variables to represent the 2 things that you are looking for, such as x and y. But you can use any 2 variables that you choose. Like if they're talking about nickels and dimes, you can use N and D to keep them specific. Make sure you draw it if needed. Drawings always help you visually make sense of it. Propose a solution. I wouldn't really propose a solution. That's just guessing and checking. Just do the math and it's way easier that way. But make sure it makes sense. Translate it. So when you read it, translate it into an equation, solve it, interpret your results. So make sure you're answering the question that they're asking. So for example, we'll start out with something really simple. So one number is 4 more than twice the second number. Their total is 25. So we are going to get this pen where it writes then. All right, so one number is 4 more than twice the second number. So we have 2 numbers. So let x be your first number. So x is the first number, and let y be your second number. And their total is 25. So we know that we have 2 numbers, and we know that their total is 25. So if I were to add these 2 numbers together, they would add up to 25. So that would take care of that equation. Now one of your numbers, x or y, is 4 more than twice the second. So I'm just going to say, okay, x is 4 more than, so I've got to add 4 to something, and that's twice the second number. So I said the second number was y. So now I have 2 equations. Well, since one of the numbers is equal to something, substitution method would be easiest on this one. So what I'm going to do is I'm going to take this piece right here and I'm going to replace x with what x is actually equal to. So I'm going to rewrite this equation. So x is 2y plus 4. Then I'm going to do plus y equals 25. So now I've got y plus 2y plus y, which is 3y plus 4 equals 25. I'm going to subtract 4 from both sides. 3y is equal to 21. Divide both sides by 3. And y is 7. So now that I know that y is 7, I can turn around and plug it into this formula here. X is 2 times 7, because y is 7, plus 4. X is 14 plus 4. X is 18. So my 2 numbers, x is the first number, y is the second number. So that's how you would do those type of problems. All right, so what they've done here is they're going to talk about it in a little bit more detail. I'm not going to go over all of these slides, but I did make a copy of this in PDF form, and I've uploaded it as well so that you can look at everything that this says. It's just stating to read and reread the problem, just all those steps that we went over. And it talks about the first number, which is 4 more than the second number, or 4 more than twice the second number, sorry. And they're saying, okay, suppose this or that. So if one of them is 14 and one of them is 5, that equals 19. So your solution is incorrect. Like I said, no need to guess and check. Here they're talking about translating it to make it into the equations, writing the system using substitution as I suggested, and then replacing it. So it's got all of this in here. Like I said, I'm not going to go over exactly word for word what they have here, but I did make a PDF of it so that you can see see it all spelled out. All right. So now our next example, Hilton University Drama Club sold 311 tickets for a play. Student tickets cost 50 cents each. Non-student tickets are $1.50. If the total receipts are $385.50, find how many tickets of each type were sold. So again, you're going to read the problem. So suppose the number of tickets. Again, I'm not going to guess and check. I'm going to set up the equations, but this is how they're looking at it. They're saying to use S and N. So S for student tickets and N for non-student tickets. That way you don't get your X's and Y's mixed up. And then my computer has a little bit of a drag today. So here they're saying Hilton University Drama Club sold 311 tickets. So you know your student and your non-student tickets are $311 and their receipts are $385.50. So if the student tickets are 50 cents and the non-student tickets are $1.50, then 50 cents for every student, $1.50 for every non-student equals $385.50. And then you solve it. So what I'm going to do is go through here. Okay. So we know that we have student tickets, which we said are S, and then we have non-student, which is N. So we know that student tickets plus non-student tickets are 311. We know 50 cents for every student ticket plus $1.50 for every non-student is $385.50. So that comes from the word problem. So what I'm going to do here is you can leave the decimals if you want, or you can multiply everything by 100 so that you can get rid of the decimals if you want to clear the decimals. I'm really not going to clear the decimals because I'm going to be using my calculator. But what I am going to do is I'm going to use the elimination method. So if I go here, all right, so what I'm going to do is I'm going to multiply this equation right here by negative 50 cents. And I'm going to get rid of the student tickets. So if I multiply this by this, I get negative 50s, and then I'm going to multiply this times this, and I get negative 0.50n, and then I'm going to multiply it by 311. So negative 50 times 311 is negative 155.50. So now I can take and add those two equations together because this one became this one. So I'm just going to put a little line through this because I don't need it. So now I know 50 cents minus 50 cents cancels out. $1.50 minus 50 is $1.n. And then 385.50 minus 155.50 gives me 230. So 1n equals 230. Well, if 1n equals 230, then n is 230. So that means there are 230 non-student tickets. Well, if you go back to the original equation here, well, all right. So we know student tickets plus non-student tickets equals 311. Well, if non-student tickets are 230 equals 311, so I can do 311 minus 230, and I get that student tickets are 81. So those are your two answers to that problem. So always make sure, identify what variables you're going to use and what they're equal to so that you don't get them confused when you're working your math problem. All right, so 81 student tickets, 230 non-student tickets. Oops, back up. All right, so Terry Watkins can row about 10.6 kilometers in 1 hour downstream. So think about when you're going downstream, you're going with the current, so you're going to be going faster. And 6.8 kilometers upstream, so you're going to be moving slower because you're working against the current. Find out how fast he can row in still water, and then find the speed of the current. All right, so this one I'm going to show you how they're working it out. All right, so what we need to do is the basic formula for distance is rate times time. You need to know this formula here, okay? So make sure that you know this one, okay? So distance equals rate times time. So if you are traveling downstream, that would be R plus W. And if you're traveling, so downstream is R plus W, upstream is going to be R minus W, where R is the speed of the rower in still water. So if there was no current, if it was just still, R is your speed, and W is the speed of the water current. So however fast you're going plus the speed, that's why when you're going downstream, you go faster. And the speed you're rowing minus the current, because you're working against it, is going upstream. So now it says, suppose Terry can row 9 kilometers in an hour in still water, and the water current is 2 miles per hour. So this is where they're taking and doing a proposed solution. Like I said, I would not do proposed solutions. I think they're more confusing. Just set up the problem, okay? So here's your two variables, R and W. All right, so the rate downstream is R plus W. The time, he only rowed for 1 hour and his distance was 10.6. So when he's going downstream in an hour, he can go 10.6 kilometers. Now upstream, it's R minus W times, because remember you're doing distance equals rate times time. So you're using that distance formula. He still only rowed for an hour, but since he's working against the current, he didn't get near as far in an hour as he did going downstream. So now let's look at what that looks like. So R plus W, because when you multiply by 1, nothing happened. Now if he had gone 2 hours, then you would have had to distribute the 2. So let's look at it like this. 1 times R plus W equals 10.6, so R plus W is 10.6. And then this one would be 1 times R minus W equals 6.8. So R minus W equals 6.8. So you have your two, let me slide this over here. So you have your two formulas, which is where, well, I just moved that right in my way. So now here's your two formulas. So what you'll notice is that the W's, one is plus and one is minus, so I will be able to eliminate W and find out what the R is. So when we add them together, they cancel out. So you get 2R equals 17.4, divide by 2. So we find out your speed of rowing is 8.7 kilometers per hour. So now I know if I plug that back in, 8.7 plus W, and then subtract, I find out that W is 1.9. And if you were to plug it back in, you would see that it is true. So the interpretation is Terry's rate in still water. So his speed in still water is 8.7 kilometers per hour, in the rate of the water current is 1.9 kilometers per hour. So this would be interpreting your work. All right, so our next one is talking about basically mixing things. So if you're going to mix 2 kinds of oil or 2 kinds of gas or 2 kinds of snacks to make your own trail mix or whatever. So Candy Barrel Shop Manager is going to mix M&Ms that are $2 a pound with trail mix, which is $1.50 a pound. How many pounds of each should she use to get 50 pounds of a party mix? That's $1.80 a pound. Because obviously you don't want to mix them and charge $2 because you're not getting just M&Ms, or $1.50 because you're not just buying trail mix. So she wants to charge $1.80. So the way this looks is, okay, understand the problem. So you've got your price per unit. So that's either going to be your $1.50 or your $2, sorry. The number of units, and then the price of all the units. So don't do a proposed solution. They're saying guess and check. So here we go. So we're going to use X to be the M&Ms and Y to be the trail mix. You could use M and T if you wanted for M&Ms and trail mix. Like I said, it doesn't matter. You can use whatever variable you want that makes sense to you. So we are going to need 50 pounds of party mix. So we know M&Ms plus trail mix, however many pounds of M&Ms plus however many pounds of trail mix has to equal 50 pounds. So the price of M&Ms times the price of trail mix equals price of the mixture. So we've got 2 times M&Ms, because $2 per pound, $1.50 per pound of trail mix, and we're going to charge $1.80, but we know we're going to need 50 pounds. So that's where this comes in, which is equal to 90. So what you wind up having is 2x plus 150y equals 90. So don't forget this part right here. You're just going to have to multiply how much you're going to charge by how much you're going to need to get that number so that you can come up with your first equation. Or your second equation, sorry. All right, so we know M&Ms plus trail mix, 50 pounds total. The price of M&Ms plus the price of trail mix equals 90. So here, since we have, they're both in standard form, we're going to do a elimination method. So since the equations are written in standard form, so multiply the first equation by 3, and we get 3x plus 3y equals 150. We're going to multiply the second equation by -2, which will also get rid of our decimal, okay? So -2 times 2 is -4. -2 times 150 is -3. And then -2 times 90 is -180. And then here, we're able to cancel out the trail mix. So we're going to find out how many pounds of M&Ms. So we find out 3x minus 4x is -x. 150 minus 180 is -30. Divide both sides by -1. We get 30 pounds of M&Ms. Well, if it's 30 pounds of M&Ms that we need, and when you plug that back in, you get 20 pounds of trail mix. So if you plug them back in, you'll see that both of them are true when you check. So overall, the store manager needs to mix 30 pounds of M&Ms and 20 pounds of trail mix. When you're doing this in my math lab, it's going to ask you for both. Make sure you don't reverse them when you plug it in, because if you reverse them, if you said 20 pounds of M&Ms and 30 pounds of trail mix, you will get it wrong. Even though you did the math right, you plugged it in incorrectly, so be very careful. All right, so cost and revenue. If you're going into business or looking into any kind of business degree, this is pretty important. So a company that manufactures boxes recently purchased $2,000 worth of new equipment to make gift boxes to sell to the customers. the cost of producing a package of gift boxes is $1.50, and they're sold for $4. Find the number of packages that must be sold for the company to break. Ooh, it's supposed to be break even. I lost my word on there. Break even. So, understand the company will have a one-time charge or a one-time cost of $2,000 because they had to buy the equipment. And they're going to pay $1.50 per packaged product. The revenue will be $4 per package. So X is going to be your number of packages of gift boxes. So, because you're asking how many gift boxes do we need to do to sell, to make, however you want to look at it, so that they break even. So C of X, this is going to be this is the kind of Y1 and Y2 if you're thinking about it calculator wise. So C for cost, R for revenue, and then you have your number of package of gift boxes. So revenue, the revenue is what you make. So $4 for every gift box. The cost is $1.50 for every gift box, plus that $2,000 startup fee. So there are your two equations right there, cost and revenue. So now we are going to, since the break-even point is when they're equal, that's why it's called break-even, because they're equal. So when your cost, so if you think about your cost being a line like this, because you started with nothing and then you paid your $2,000 startup fee and then you paid $1.50 per box, it's going to go one way and then your revenue is going to go another way. So just showing you the break-even point is where they intersect. Anything after, so this would be your revenue, this would be your cost, this is where they break even. So once you get to break even, anything past here is profits. So since the break-even point is when they're equal to each other, then set the revenue equal to the cost. So subtract your $1.50 per box, and you get $2.50 per box equals 2,000. And then divide by that 250, and you find out that you will need to produce 800 boxes to break even. So if you only produce 799, you're still in the hole. If you produce 801, then you start making a profit. So if you plug it back in, you'll see that when you plug in 800, you see that the revenue is 3,200 and your cost was 3,200. So you have to sell 800 packages of gift boxes to break even. All right, so solving problems modeled by systems of 3 equations. We're not going to do 3 equations. I'm going to show y'all a much easier way to do this problem. The measure of the largest angle of a triangle is 90 degrees more than the measure of the smallest. The measure of the remaining angle is 30 degrees more than the measure of the smallest. So find the measure of each. So draw a picture. We have a triangle. So we have a small angle, we have a middle angle, and we have a large angle. Your picture does not have to match exactly the way you label it. But we know that the largest angle is 90 degrees more than the smallest angle. But yet they didn't tell me anything about the smallest angle. So I'm going to say my smallest angle is X because I have no idea what it is. The largest angle is 90 degrees more than that. So whatever my small angle is plus 90, that's the large angle. The remaining angle, which would be my middle angle, is 30 degrees more than the smallest. So this one is X plus 30. So now I know all 3 angles have to add up to 180. So triangles equal 180 degrees. So you have your small angle plus your middle angle plus your large angle. All together, they have to add up to 180. So the small angle is X. The middle angle is x plus 30, and the large angle is x plus 90. Altogether equals 180. So x plus x plus x, that's 3x. 30 plus 90 is 120. So now I can subtract 120 from both sides, and I'm left with 3x equals 60, and then divide both sides by 3, and I get that x is 20. So that means my smallest angle is 20 degrees. So if I go up here and I put that this is 20 degrees, well, this one is going to be 20 plus 30, which is 50 degrees. And this one is going to be 20 plus 90, which is 110 degrees. So if you added them together, 110 plus 50 plus 20, you get 160, 170, 180. Check. So you only had to find x. So what they've done is they did the small, medium, and large just as I did. And they said the large was the 90 plus small, the middle is 30 plus small. They're using 3 different variables, where I just used x. And then they substituted everything in. They did it the same way. I just go about explaining it a little bit different, but you can see that it's true for all cases. And that is the end. And I will see y'all next time.